All right, we're going to talk about division. Now, division can be a little tricky, okay? Because we're going to treat it different when you have a monomial on the bottom versus when you have like a binomial on the bottom. It has like different rules. When you have a monomial on the bottom, basically you can look at the monomial as the common denominator between all three of these terms on the top. So you can rewrite it like this: 6r squared s squared over 3rs plus 3rs squared over 3rs plus negative 9r squared s over 3rs. You with me so far? Okay, it's just a common denominator across the board. Now what I can do is I can apply the rules that I know when I have like monomials. Okay, go back to that very first section that we had where we had the monomials, and we go, okay, the 6 and the 3, what am I going to do there? I'm going to go ahead and divide, or I'm going to go ahead and reduce down. 6 divided by 3 is what? 2. So what I can do is I go, well, that reduces down to, and if I want to put a 1 on the bottom, I can, but I'm not going to need it, okay? Then I have the r squared and the r. How does that reduce?
Just R.
And is it on the top or the bottom?
Top.
It's on the top, because remember what we do is we subtract the exponents and then place it where the larger exponent is. So I have 2 minus 1, which is 1. The larger exponent is on the top, so that r stays on the top. It's an r to the first power on the top. How about the s? Just s, and it's on the top, right? Okay. Then I go on to the next term. What about the 3 over 3?
1.
It's just 1, okay? And I can put, if I want to, I can put a 1 on the top and a 1 on the bottom, okay? Later on, I'm going to let go of that. But how about the r? What's that equal to? 1, okay? So if I want to, I can do another 1 here. But you know when I multiply by 1, it's not going to affect it. Okay, what about the s squared and the s?
Just an S.
Just an s is on the top or the bottom?
Top.
Top. Okay. Then I go on to the next one. What about the negative 9 and the 3?
Negative 3.
Negative 3, and is it on the top or the bottom?
Top.
It's on the top, because that's the same as negative 3 over 1 if you go to reduce it. So I have a negative 3 and I have a 1 on the bottom. Okay, now remember, that's a negative on a coefficient. That's on a negative on the exponent. Okay, how about the r squared and the r?
R.
R on the
Top.
top or the bottom? Top. Okay, how about the s?
1.
It's 1, so if I want to, I can do that. Okay, now let's go through. I got a lot of 1s there that I don't need. Okay, do I need this 1 on the bottom? No, so I'm going to rewrite that as 2rs. Okay, I've got a 1 times a 1 times an s, and a 1 times a 1. What do I really have?
S.
S. Okay, I've got a bunch of 1s there. What do I really have?
Negative 3R.
Negative 3r. And that's it. Okay, very simple. Just understand that the monomial is distributed with all of that. Okay, very quickly, I'm going to give you one to try, and then we're going to go on from there. Okay? Now, you do not have to write all those ones out. I did so that you could see where they were, but you are certainly not required to do that. You can do that in your head. All right, do that problem, and then we're going to move on. get it, Kelly? Okay. All right. We're going to move on and we're going to put a binomial on the bottom. Whole different ball game. Okay, totally different ball game. And it is probably the thing that trips people up the most in this chapter. Let's say I have c squared minus c minus 30 over c minus 6. Now, the temptation is to try and reduce those c's and to reduce the 30 and the 6. You cannot do that, okay? This whole thing has to stay together. You cannot separate it out, okay? So I can't just if this thing goes away, the whole thing has to go away, not just part of it, okay? So therefore, I'm gonna have to do this a different way. I can't reduce it like I've done before. What I literally have to do is I have to divide it, okay? There's two ways. Actually, I'm going to show you another way besides just those two ways, okay? My first way is like a shortcut way, okay? I'm going to, and this is going to require you to remember some stuff from Algebra 1, which we're going to get into very shortly, but we'll see. You might already remember it. I'm going to factor that top, okay, into two sets of parentheses. So I have a C and a C, and I have a 6 and a 5. Okay, y'all remember doing this? Okay, this times this has to give me this. This times this has to give me that. Then I go and I go outside, inside. 5C, 6C. I'm going to need to add those together and get a negative 1. So this needs to be negative and that needs to be positive. So therefore my minus is going to go there and my plus is going to go there. Y'all remember this? Okay. This is my shortcut way. Doesn't always work because you can't always factor it. But on this particular one, it works like a charm. Okay? Notice on the top, in parentheses, I have a C minus 6. On the bottom, I have a C minus 6. Remember how I said that you can only get rid of it if the whole thing goes away? Well, as long as that's multiplied up there on the top, that's like reducing this down to 1 over 1. So I quickly go, you know what? That's equal to that. Okay? That's the easiest way to do it. If you can do it that way, like I said, not all of them factor and not all of them cancel out like that. Okay, so let's say we didn't remember that. Okay, and we got to do it the long way. This is a method called long division, and you probably go, oh, I remember long division. That wasn't my favorite thing to do. It's a piece of cake with polynomials. Okay, much, much easier. So you have C minus 6 divided into C squared minus C minus 30. Okay? All I do is I look at the very first term. C times what gives me C squared? C. So I'm going to put a C on the top, but I'm going to put it over the second term because remember, I've got a binomial going into that. So I go C times C is C squared. C times negative 6 is negative 6C. Now remember long division, I'm subtracting. If these two don't match up, you've done something wrong because your first term should always match up. So I have a negative C minus a negative 6C. Okay, so negative C minus a negative 6C, right? Because you have subtraction with division. I'm adding the opposite of the second number. So that's going to give me a 5C. Then I bring down the next term, minus 30. Now I go, C times what gives me 5C? 5. A positive 5. So I say plus 5. So 5C minus 30, and that sucker matches right up. I have no remainder. Same answer I got there, right? Okay. Third method. Okay, now this one's one that you might not have experienced. Synthetic division. Okay, this is my favorite. Okay, it's actually the favorite. Now, at first it seems weird. But after you do it more and more, you're going, oh, I like this because this is addition, not subtraction. People don't like the subtraction over here. Okay? Now, all of these methods, like I said, the first method, that doesn't always work because you can't always factor it. Second method, always works. Third method, synthetic division, it kind of depends on how it's set up. Okay? So this is as it helps to spell it right. Okay, synthetic division requires your divisor to be in an x minus r position. Okay, now we have an x minus r. This is your x minus your r. The r, which in this case is 6, goes out here in a half a box. There's no technical term for this half a box. Okay, you can make up a term if you want, but there's really nothing there. Okay, then what I do is I write down the coefficients. Okay, so I have a 1, a -1, and a -30. Now, those coefficients have to be in descending terms. So I have a 2, a 1, and a 0. If I don't have all those terms, let's say I went from a 2 to a 0, I'd have to put a 0 as a placeholder right here. Okay? Same thing with long division actually, and we'll get to some of those. All right, so here's the method. Real easy, but it's real different. You know, at one time you didn't know how to do long division. So this is your intro into synthetic division. Once you get the method down, it will become easy. You bring the first number straight down. Okay, so the 1 comes down. Then I multiply. 6 times 1, and I place. Okay, then I add. Remember I told you you're going to add instead of subtract? Then I go 6 times 5, and I place. Then I add. If I get a 0 on the end like that, that means it has no remainder. You go, okay, well that's kind of stupid looking. All right, then what I do is I use the 1 and the 5 to make my answer. And I do a method that's called a depressed polynomial. I guess it's a polynomial that's had a really bad day. Okay, he's a very depressed polynomial. If my original problem has a 2, then I go 1 down. I depress from my highest exponent. Okay, 1 down from the 2 is a 1. So the 1 goes with the, well, actually it's a c. Goes with the c to the first power, and then I just add the 5. Okay, so if I started with a 3, I would start with a 2 down here, and I would go c to the second, then c to the first, and then my number. At first this is really weird. So this gives me a c plus 5. Look at this. Same answer, 3 methods. Okay? Now, sometimes right here at the beginning, they're going to tell you exactly what method to use. Sometimes they're just going to let it up to you. Okay? Long division is always usable. All right, let's look at this next one. Let's say I have this. You go, wait a minute, I thought we were doing division. We are. Okay, what does that -1 mean?
Over 1.
It means
Under
it's
1.
under 1, okay? Which means another way to write this is that. Okay? Now I'm back with division. Now I look at this and I go, got a few problems here because this doesn't really match up with that well. I would need to switch the order here to be able to do long division, wouldn't I? So how can I switch that order of the s minus 6?
And the opposite.
I can add the opposite. Okay, so if I add the opposite second number, I can turn around and go, oh, that's -s plus 6, isn't it? So then I can divide and I can go s squared. Apparently there's a problem here. This was supposed to be an s. That makes more sense. Okay. So I've got that. All right? So I go through it, I'm gonna do long division on this one, because factoring it and getting a negative, that'd be kind of weird. Okay, now it's doable, but kind of weird. Okay, negative s times what gives me s squared? Negative s. Okay, so I have a negative s. Now remember, I'm going to put it over here because I have a binomial. So that first one has to match up. Then I have a negative 6s. Okay, I'm subtracting. So I have 4s minus a negative 6s. That's going to give me a 10s, right? Bring down the next one. Minus 16. Now what do I have to multiply by the negative s to get 10s? Negative 10, okay? Because I want a positive here, okay? So make sure you're being careful with your positives and negatives, because a negative times a negative is a positive, okay? So I have 10s minus negative 60, right? Would you agree with that? All right, so then I turn around and I go, well, that's not going to give me 0 at the end, so let me go ahead and subtract it. Negative 16 minus a negative 60, I'm going to add the opposite. I'm going to get a positive 44 here. That's my remainder. Okay, now, gone are the days where you can just write R44. What you're going to do is you're going to take that and you're going to place it over top of your divisor. So, erase this. It's going to become plus 44 over negative s plus 6. That's going to be my answer. Okay? Now, could I have done synthetic division on it? Well, the problem is it's not set up in x minus r. Okay? Even if I turn it around and I have negative s plus 6, it's still not in x minus r. I would have to divide everything by a negative to get it there. Okay, so sometimes you would just choose not to do synthetic division on it. It would be way easier to do long division. Okay, now we're going to get to some that they tell us we have to do synthetic division on. Okay, let's look at this one. All right, I've got this. I can do long division on it, or I could do synthetic division on it, because it's set up in x minus r, isn't it? Okay, do you understand what I mean by that?
What's supposed to be on the bottom of the fraction?
Okay, this, look, this is divided, right? So that's the same thing as saying 6x cubed minus 19x squared plus x plus 6 divided by x minus 3.
It just looked like a 1.
Okay, yeah, this is a division thing. I agree. Should just be a dot. Okay? Now, I can do long division. I can do synthetic division. Okay, long division you're okay on, right? For the most part? Okay, we'll do both. We'll do both. Oh, I gotta reset my thing here.